Hi, my name is Hajira Sheikh. I will present the final project for the knowledge management tools and technology, and my topic is on building information modeling. Building information modeling, information is normally traded, utilized the industrial foundation classes. Standard BIM model is complement for information that is made during the plan and arranging stage and is rich wellspring of data for the charging stage in which building demonstrate our pro to activity. And this activity, as you can see on this on the presentation, the picture, it shows that service, design, simulation, document management, faculty management, and so on. So the data availability and organization for the BIM. So BIM data for automated generation of control strategy for energy system, therefore simplify and accelerating the commissioning phase. In this PowerPoint, I'm presenting a methodology to create control strategy of building heating system and air condition, HVAC. Heating and cooling HVAC system, energy provision system, consists of a combination of energy provisioning and storage components, which are typically connected by a transport medium, typically like water with a link to the air-based ventilation system. The component can be classified into different common types, which are found in many buildings. While the components are rather standardized, the hydraulic connection depends on the design init of the planner and can vary in their realization. In this picture, it shows that in this picture, it shows that it has been made the scope of the heating case without hot tap water supply in the regarding the cooling case. Initially left out, it only shows the heat pump without showing the AC. So with the distribution system, only low temperature floor heating system is available, leaving out high temperature radiation. In addition, only the most common energy components are included in order not to inflate system complexity. So the heating provision elements based on the superstructure. As you can see on the table, like element marked with X are required for a variant. For thermal energy storage, different hydraulic combinations are possible. In general, multiple heat storage can be connected in parallel or serial in both positions. So development a SIMULINK block for different type of heating have three types of variable. A design parameter, the second variable is process variable, and the third is the dynamic output. So the first one, design parameter, are unchangeable during the routine of the control strategy and include, for example, the orientation and position of the VB system, as well as inclinations and size, windows location, and the size of the window. Process variable. So the second variable is the process variable and dynamic out. And the third variable, the dynamic output, may change anytime and affect the overall system. A heating curve based on predefined support point. Heating is usually used to provide a predefined flow temperature, which can be target temperature of the underfloor heating or of the storage tank. The target temperature of the underfloor heating is determined. And the heating system derived from the superstructure, including actuators. And this in this picture, as you can see on the PowerPoint, the test case shown, the pump drain and the pump storage are used for controlling the mass flows of the source and the sink side of the heat pump. On both sides, the BI controls are used. Pump drain change the mass flow for reaching a specific temperature difference between a prime intake and return. the sensor and the actuator within the heating zone for the room, the heat pump model, as you can see, whose terminal output power is calculated based on the terminal input, and the electrical power as well as the temperature is spread between source input and sink output temperature. In this test, the terminal storage corresponded to decoupling of the supply and distribution side. The calculation of the inner temperature are obtained by heating load calculation. The heating system in use in this case, underfloor heating, is simulated and the heat lost and gain are taken into account. Automatically created baseline role strategy for the heating system for a single room. The topology map, as you can see on the picture, the input and the output of the provisioning component are derived and are matched with the component names on the topology map in order to reflect the hydraulic connection. The provision side is representing from pump storage out of the photovoltaic system, and the distribution side from the thermal energy storage discharge out to the pump heater out. A distinction is made between inputs and output, which also define the flow direction of the liquid side. And to be more specific, what is the topology map? Here is the list of the source for the topology map and what is the sink based on the topology image. As you can see, the source is based on pump storage out and pump storage and the heat pump hot out, and value HBG, FB out, value switch out, and so on. And the sink is start from the heat pump hot in natural gas fired boiler value HB, GFBN, and so on, all the way to the thermal energy storage discharge in. So the flow, what is the flow temperature? So the flow temperature, supply temperature, and back mixing value position from the room temperature controlling the opening of the maximum value to achieve the desired flow temperature and the maximum flow temperature as it shows on the first graph and the second graph. So the conclusion, developing methodology for HVAC system for structure to impact a various control methodology, including changing indoor temperature, set points, and pre-cooling, which depend on a state-based model of Solarity Family House. The company utilized the BIM tool for future developing indoor air quality to deal with general control techniques and to dismiss structure energy utilization. And this is only based for the company I work for. And the last slide is the reference, where reference 1 and reference 2. Thank you for watching my presentation and have a great day.